that's fine, right?
I put another, let me just try, let me just make sure.
I'm Robert Cosi. I'm the publisher of Canadian Contractor, and I'm here at the warehouse of ITW, and this is Gustavo
Angola.
Thank you. Gustavo Angola, and he is the technical specialist for ITW. Gustavo, we use fasteners all the time. Tell us how you test them in your factory or in your test facility.
Okay, so when we're coming out with or when we're evaluating a fastener, there are three main things that we look at. We look at how it performs with the base material that it's intended to go into.
Yep.
So how it interacts, how the pull-out is. Then the other thing we looked at is the strength of the fastener on its own. Okay. So that basically comes from the steel, the diameter, those will define that. And then the third thing I would say we look at is the corrosion resistance. That's a key one as well, and that comes from the coating.
Okay, so now you made some drawings here on the board. Show me what you're illustrating here with regards to fasteners.
So if we're talking about, let's say, screw to fasten wood to wood together, there are, I would say, 5 different failure modes or failure mechanisms that you will look into. You will look into the main one that I talked about, or the second one that I talked about there, which is the strength of the fastener itself. For example, this would be tension or tensile strength.
Okay, you're talking about the strength that it would take to
screw,
pull the
to
screw
break it on its own without interacting
like
with
break
the,
it by pulling it.
By pulling it, yeah.
Wow.
Yeah. We usually put it in a tensile tester machine and we pull it until it breaks.
Okay.
The same thing you can do for shear. You would pull, let's say, half the screw in one direction and the other half in a different direction, and then you would see how much it would take to break it there. That's called shear. And again, here we're only looking at the steel strength, or the strength of the fastener on its own.
This doesn't make any reference to the substrate that it's going into.
Yeah, it doesn't. So when we're looking at how it interacts with the substrate, we'll take the example of a wood screw in the main member down here, and then the side member up here. There are 3 different failure modes that are typically evaluated. You can have the side member going in one direction and the main member going in a different direction. This could generate withdrawal failure or pull-out. Basically, the screw pulls out of the bottom member.
Gotcha.
That's typically where the threads are going to be engaged, in that main member down there. The other failure you can get, depending on what's the strength of the wood itself, what dimensions we're seeing here, you can get a pull-through failure. Basically, it's when the side member pulls through the head, and it will come from the same movement between the 2 different boards.
I see.
So the bottom one, the main member will be going one way, the side member will be going a different way. Depending on how this works here, you can get a pull through. Basically, you break through the top member or the side member.
Which is exactly what you don't want, because what you're describing to me here is the 2 members that you're trying to pull together getting pushed apart.
Yeah, exactly.
Gotcha.
And then the bottom one that we're looking at here would be how the screw performs when one wood member wants to go in one direction and the other wants to go in the opposite direction. This is called lateral strength, and basically it's going to be determined by how strong the wood is and how well designed the screw is in terms of threads and diameter. All that comes into account with this one.
Okay, what is this one called again?
This one's called pull through. The other one's called pull out. Pull out. And then this will be lateral strength here. You definitely don't want is your screw breaking before it pulls out.
Right.
And that's going to be determined by this. I see. So if the steel's not strong enough, then this might happen before this. And you definitely don't want the screw to break. Obviously you want it to hold as much as it can to the main member, but ultimately the wood's going to give in, and eventually the failure might happen if you get to a certain load.
Yeah. Okay, so you can test this all in a lab, essentially.
Yeah, this is pretty much what we test, and the data that we develop, it's based on this sort of testing.
Okay, so listen, next time we're going to get together and you're going to describe to me what design or what happens with the screw design in order to avoid these kinds of problems.
For sure.
All right? Yeah. Thanks, man.
Yeah, no problem.